Morning. Can you hear me?
Yes, ma'am. Yes, ma'am.
Okay, so only 78 students are there. Where are the others? Okay, anyway, so maybe we'll start with the last class revision, and then we can move on. So maybe the following numbers I want to check whether you are here. AG 73, are you here? AG 73. No? Okay, AG 72.
Yes, ma'am.
Okay, AG 49. AG 49.
Yes, ma'am.
Okay, 54.
Yes, ma'am.
107. 107.
Yes.
Okay, AG 11. AG 11.
Yes, ma'am.
AG 111.
Yes, madam.
AG 91. 91. No? Okay, 121.
Yes, ma'am.
Okay, 131. 131. No? 141. 141. Okay, so now let's see about maybe the last in the last class we had a poll, and first of all we can discuss those, and then we can move on to the other questions. So first one is bulk density of soils are always higher than particle density. So that was the question given. AG 72, can you tell whether it is true or false?
False.
Bulk density of soils are always higher than particle density. False.
False. False, ma'am. Particle density higher than bulk density.
Yeah, okay. So that is false because particle density we are dividing by volume of solids only. So the particle density will be definitely higher than bulk density. Okay, thank you. Next, bulk density of a soil is influenced by mineral matter, organic matter, and water content. So AG 49. Can you answer for this? Bulk density of mineral soils can be influenced by which of the following? Mineral matter, organic matter, water content. Quickly,
Yes,
please.
ma'am.
Yes, which are the correct answers?
Organic matter can be influenced bulk density.
Okay. What about mineral matter?
Mineral matter.
Yes, AG 54. Can you answer for that question? Mineral matter, organic matter, water content.
Organic matter, ma'am.
Only organic matter. What about mineral matter? Will it influence or not?
Not influenced.
Bulk density will not be in MS over VT. Okay. So even the mineral matter will is the more contributor of mass of the soil than organic matter. So it is a multiple choice. You can choose more than one answer. So you have to choose mineral matter as well as organic matter. Okay, but water content is not, it will not influence because MS over VT. So in MS, it is only the dry mass. So in the dry mass, organic matter and mineral matter will contribute, not only organic matter. Okay. So maybe if the soil is composed of heavy minerals, then those will have higher bulk density, definitely. Okay. But water content will not influence because in the volume is also it will not be included, and also because volume includes macropores and micropores, so water content will not influence. Okay, next question is particle density of a soil is influenced by porosity. True or false? So maybe AG 107. Particle density of a soil is influenced by porosity. Is it correct? True or false? Huh? I cannot hear you. Okay, why? Why it is not influenced by porosity?
Influence the porosity.
Huh?
Influence.
I cannot hear you. AG 91, please. Can you answer for that question? Is it correct and why?
Correct, ma'am.
Soil is influenced by porosity. Is it correct?
Yes, ma'am.
Particle density? Okay, 121. Can you answer for that question?
No, ma'am.
No. Why? Why no?
Particle density consider on solid space.
Yeah, it does not consider the pore space, so porosity will not influence particle density. So if you understand properly, you can answer. Okay, please concentrate.
Okay, ma'am.
Okay. So thank you. Then earthworms can increase the bulk density of soils. Earthworms can increase the bulk density of soil. So next person is 131. Is it correct? Earthworms can increase the bulk density of soils. 131 is not there. Okay, again 72. Can you answer that question?
Yes, ma'am. Earthworms increase the volume of pore space. So decrease bulk density.
Yeah, good. Then the next and last question of the last poll is sandy soils have less porosity than clay soils. Is it true or false? Sandy soils has less porosity than clay soils. AG 54.
True, ma'am.
Which has less porosity.
Clay porosity is 75%. Sand porosity is 35%.
Is it correct? Which has high porosity?
Clay.
Okay. So sandy soils have less porosity. Is it correct or
Wrong, ma'am.
Why? Which has high porosity?
Sorry, ma'am. Clay is high porosity.
Yeah, so this statement correct or not? Yes? True or false? Okay, so with that we'll finish the last class discussion and we can move on to this class. So I'll share the screen. And,
Recording in progress.
okay. So in the last class, we started to discuss about soil texture. So it is the relative proportion of expression of relative amount of sand, silt, and clay in the soil. Then we discussed about the importance. It is a constant property, and also it affect the physical, chemical properties of the soil, and also it affect the cultivation aspects. So since it affects all the properties and cultivation aspects, it is an important property. And if you asked, for example, an essay type question, discuss the role of texture or why the texture is important, then you have to discuss about everything. How physical properties are affected by texture, not only just list down, you have to tell how water holding capacity is affected, whether clay soil or sandy soil has high water holding capacity. Those kind of discussions we have to discuss. And also the chemical properties affected by texture we discussed in detail. Cation exchange capacity, buffer capacity, nutrient retention, all these are increased by clay, whereas leaching is high in sandy soil. And also we discussed about the cultivation aspects that are affected by texture. So the type of implements we have to use in the field, then time of tillage, that all these will be affected, then method and frequency of fertilizer application. So maybe if it is a sandy soil, we have to apply fertilizer more frequently than one big application, because otherwise nutrients will be lost. Then also irrigation method and irrigation interval. So especially the sandy soils, the irrigation method should be overhead type of irrigation or sprinkler irrigation, because in sandy soil leaching or there is quick leaching losses. So the water use efficiency will be reduced if you apply surface irrigation methods. And also the interval between two irrigation, there should be less interval between two irrigation in sandy soil, whereas for clay soil or loam soil, you can have more interval between two irrigation. So since all these factors are influenced by texture, texture is an important property. Then we discussed about the three type of particles. So sand particles, their size is based on the size only. These three particles are classified. Sand particles are normally 0.02 millimeter to 2 millimeter in diameter. They can be represented as a spherical shape, but actually they are not spherical. They vary in their shape, and they are not necessarily smooth, but they have a jagged surface, and they can be seen by naked eye. Without a microscope, you can just see them by naked eye. So because they are big particles, and they consist of quartz mineral, and also they can have feldspar and mica. and also other heavy minerals they can have. Then if you take silt particle, again the silt particle, the size is between 0.002 millimeter to 0.02 millimeter. And since the size is smaller, their surface area is more than the sand particles. Then they can be coated with clay because they also smaller in size, and the clay particles can stick together with the silt, and maybe they can be coated with clay. And they have physical and chemical properties somewhat similar to the clay because their size is almost similar. So their properties are somewhat similar to clay. And if you see the clay particles, particle size less than 0.002 millimeter particles are called as clay. Okay, so they are the very small particles, and they can be plate-like or needle-like in shape, and they are belong to aluminosilicate group of minerals. So you will study these. What are aluminosilicate? You will be studying in this semester in the chemical properties. Okay. And sometimes a considerable concentration of fine particles which does not belong to aluminosilicates are also there. They are iron oxides and calcium carbonate. These also can be found with clay particles. And normally these clay are secondary minerals, and they are derived from primary minerals. So you have studied in the first semester what are primary minerals and what are secondary minerals. Okay. So primary minerals are derived from the original rock, which are found in the original rock primary minerals. When they undergo weathering, secondary minerals are formed. So normally clay is having secondary minerals. So here is the classification of sand, silt and clay. So there are two systems of classification. One is International Soil Science Society system and United States Department of Agriculture system. So these are the two major type of classification system in the world. So this is a simple one. And normally we use this ISS system, but you should know there is another system also. So according to ISS system, sand is further divided into fine sand and coarse sand. So coarse sand means a big sand. It is the size range is 0.2 to 2 millimeter diameter. Fine sand is 0.02 to 2.2 millimeter. And silt is 0.002 to 0.02 millimeter, and clay is less than 0.002 millimeter. So that is the classification of the sand, silt and clay particles. Whereas under USDA system, the sand particles are further classified into 5 classification. And silt is 0.002 to 0.05. So somewhat bigger particles are also included in silt. And so clay is less than 0.002 millimeter. So if you are asked what are the similarities and the differences between ISS and USDA system, so can you tell the similarities between these two? Can you tell 2 similarities between ISS system and USDA system? Yes? Anyone?
The clay soil diameter is less than 0.002.
Okay. Okay, so in both systems, the clay is classified as the same size, okay, less than 0.002 millimeter. Any other similarities? Are there any other similarities? So the upper limit of sand is also the same in both, okay, because we tell soil as less than 2 millimeter size particles only we refer as soil, okay. So that is similar in both systems. The upper limit of sand is 2 millimeter, okay. So that is the those two are the similarity between two systems, and if you ask the differences you can tell them. Silt in USDA system the upper limit is 0.05, whereas in ISS system it is 0.02. And also sand is further classified into two groups, whereas in here USDA it is more complicated and more further classified into 5. And the ISS is a simple system, and also it has equal logarithmic interval between these different sizes, whereas here it is not so. So ISS is a more simple classification. Okay, so based on this sand, silt, and clay percentage, we can classify the soils into textural classes. Okay, so the combined portions of sand, silt, and clay in a soil determine its textural classification. So first of all, we have to find, if you take a soil sample, you have to separate sand, silt, and clay particles, and you have to find what is the percentage of sand, silt, and clay particles. Then, based on the proportion of these three, we can classify the soil into different textural class. Okay, so the first step is we have to find the sand, silt, and clay percentage. Okay, so we can determine the texture in two methods. One is in the laboratory, and even in the field. In the field, you can use some simple techniques, and you can classify the textural name. So once you come, you will learn how to do the texture analysis by field method. Just you take a sample, add some water, and you feel it between your fingers, and you can tell. So that you will learn later. And also in the laboratory, there are two other methods. One is pipette method and hydrometer method. So pipette method is the most accurate method, whereas the hydrometer method is less accurate. However, that method is a quicker method. Okay, so you will be doing at least one of these method in the laboratory. So here, how we separate these sand, silt, and clay. So there is a principle. It is called as Stokes law. So what this Stokes law tell is particle size analysis based on the simple principle. That is, when soil particles are suspended in water, they tend to sink. Okay, so maybe in grade 5 or grade 6, maybe you have done that. You take some soil and mix with water, and you observe it. So the sand particle or the bigger size particle will settle first, then smaller size particle will settle, and some particles will not even settle even after 24 hours. Okay, so that is settling is used in the determination of this percentage of sand, silt and clay. So the relation between the diameter of a particle and its settling velocity is governed by Stokes' law. So the Stokes' law, it relates the diameter of a particular particle and its velocity. Using that Stokes' law, we can calculate for each of the particle how much of time will be taken to settle. So using that, we can find the texture. We'll see. You'll be doing anyway. I'll just brief how we are going to do that. Okay. So because there is little variation in the density of most soil particles, their velocity of settling is proportional to the square of the radius of each particle. Okay. So this is the Stokes law, the equation. V equals 2 upon 9 rho P minus rho F divided by neta G into R square. Okay. So rho P is the particle density of the soil. So in soil we use rho P as particle density. Rho F is the density of fluid. So that means density of water, because we take a soil sample and mix with water. Maybe we take 1,000 milliliter of water and we take, for example, 100 gram or 50 gram of soil, and we thoroughly mix it in a 1,000 milliliter measuring cylinder. Okay. Then we allow the soil to settle down. So when we allow the soil to settle down, the velocity, this equation will govern the velocity of those particles. Okay, so that means velocity is directly proportional to the radius square. Okay, since all these are constant, because the particle density of the soil is constant, density of water is constant, then this is coefficient of viscosity of water, and G is acceleration of gravity. So all these are constant. Therefore, velocity is proportional to R square. Okay, so here velocity is proportional to R square. But if we take a soil sample and in a cylinder and we thoroughly mix it up and down, and if we keep it, and then we take, for example, 10 in the top 10 centimeter height, and so velocity is height over time. So to travel top centimeter, 10 centimeter, how much of time is required for each particle? So we can calculate that using this equation. Okay, so for example, if it is a clay particle, R is diameter is 0.002 millimeter. So radius is 0.001 millimeter. So H is 10 centimeter. So H 10 over T is proportional to the R square, 0.001 square. Okay, and we know all these density of soil, density of water, everything is given here. So if you put everything, then you can find the time taken for a sand particle or silt particle or clay particle to travel 10 centimeter. Okay, so for example, if we put 2 millimeter size particle here, maybe the time taken is 4 minutes or 4 seconds. Okay, for example. Okay, so that means after 4 minutes, all the sand particles will pass 10 centimeter, and what is left at the 10 centimeter is clay and silt particle. Okay, so if you take a 25 milliliter at the 10 centimeter depth, after that time, that soil will have only clay and silt particle. Okay, similarly, you allow for another time for the sill particle to travel 10 centimeter. You have to calculate that, and after that, if you take a sample, it will have only clay particle. So silt plus clay you can calculate, then clay you can calculate. So if you subtract that, then you can calculate the silt particle. And if you subtract clay plus silt from 100, then you can calculate how much of sand. Okay. So that is the basic principle of how to determine these sand, silt, and clay particles in a soil. Okay. So there may be some calculations given to you in this section. So for example, h over t, h is the height and t is the time, is proportional to the r square. Okay. So t is proportional to 1 over r square. Okay. So T1 over T2 equals R2 square over R1 square, because T1 is proportional to 1 over R1. So if you put T1 over T2 equals R2 square over R1 square. So you should know this equation. That is, for example, T1 is time taken for sand particle, T2 is time taken for silt particle. Okay, equals to radius of silt particle square divided by radius of sand particle square. So please note down this equation. T1 over T2 equals R2 square over R1 square. Okay, so I'll give you some, please do that now. So if a 2 millimeter size particle take 1 minute to travel 10 centimeter in water, how many minutes will it take to travel the same distance in water for a 1 millimeter size particle of same density? So can you do that quickly? So I have already given you the equation. Please again take down this equation if you want. T1 over T2 equals R2 square over R1 square. Okay. So now can you do this sum?
Four minutes.
4 minutes. Any other answers? Yes. So which will move quickly? Sand particle, 2 millimeter size particle or 1 millimeter size particle? Will move quickly. Which will settle first?
2 millimeter.
2
Yeah.
millimeters.
Okay, so the answer is correct. T1 over T2 equals R2 square over R1 square. So for the particle given, it is 1 minute over T2 equals R2 square over R1 square. Okay, so T2 you can calculate 4 over 1, so that is 4 minutes. Okay, so similarly, maybe other particle sizes may be given, and you should be able to calculate. You should be able to do such calculations. Okay. So next is so now. So before you do the experiment, you have to do some treatments for the soil. Okay, because in the soil, the particles can stick together and form aggregates. For example, clay particles and silt particles. Clay particles have a sticky nature, so they can stick together and form a big particle, and that particle maybe have a size of sand particle. Okay, so if you do not separate these aggregates and do this particle size analysis, you will be overestimating the sand particle. Okay, because according to this, you classify these clay particles as sand particle because they stick together and have a size of around 2 millimeter or more than 0.02 millimeter. So actually they are not sand particle, but they stick together and form sand sized particles. Okay, so if you do not break them, then you will overestimate the coarse particles or underestimate the small particles. So to avoid that, you have to do some primary treatments. So these are the primary treatments. So first one is addition of hydrogen peroxide. So before you add water and allow the particles to settle down, you have to add hydrogen peroxide to the soil, because hydrogen peroxide will destroy the organic matter. So normally these particles maybe stick together by organic matter. Okay, so if you destroy the organic matter, these particles will come as independent particles. So for that, you can use hydrogen peroxide. So you have to treat the soil with hydrogen peroxide and allow some time so that the organic matter is broken down and the particles will come as individual particles. And also sometimes carbonates in the soil can also bind the particles. So in that case, you have to dissolve the carbonate. To dissolve the carbonate, you add some hydrochloric acid, some diluted hydrochloric acid you add and allow some time so that the carbonates will be dissolved and the particles will come independent. Okay. And the third one is there are some other binding agents such as alumina, ferric oxide or Mn manganic oxide. So they also can bind the particles together. So in that case, you have to add some sodium dithionite. So that if you treat the soil with this sodium dithionite, then these sesqui oxides, so these oxides will be removed and soil particles will come as independent particles. And finally, after you treat everything, you have to add some calgon, or this called, the chemical name is sodium hexametaphosphate. Okay, because if this sodium hexametaphosphate or calgon contains sodium ions, so this sodium ion will disperse the particles. Otherwise, if you add water, maybe these clay particles may come together and again form the aggregates. But if you add sodium, it will repel, the particles will repel each other and they will not come together. Okay, so you'll study more about that in the chemical properties. So all these primary treatments are done in order to keep the particles individually so that you can find or you can estimate the real sand percentage, silt percentage and clay percentage. And so after you find the sand, silt and clay percentage, so that you will be studying in the practical class how to find this sand, silt and clay percentage in detail. You will study and you will do that in the practical class. So after that, you separate the sand, silt and clay particle. Using this textural triangle, you will find out what is the textural class name of the particular soil. Okay, so so how to use this textural triangle? So since soil textural classification include only mineral particles and those less than 2 millimeter diameter, so sand percentage plus silt percentage plus clay percentage will be 100%. So in texture determination, we do not consider organic matter. We only consider about the mineral matter or soil particles, not the organic matter. So knowing the amount of any two fractions automatically fixes the percentage of third one. So if you know clay percentage and silt percentage, then 100 minus clay plus silt will give the sand percentage. So to use the diagram, so first of all, you have to locate the percentage of clay and project inward. Okay, so if, for example, 30% sand, 30% clay, and 40% silt. Okay, your soil has 30% sand, 30% clay, and 40% silt. So here you have to locate the 30%. Okay, then you have to draw a parallel line from for silt. You have to draw a parallel line. Then again, if the clay percentage is 40, then you have to draw a parallel line to the sand from 40. So both lines will intersect in one place, and that intersection point, where that intersection point comes, that is the textural class name of your soil. Okay, so that is how you use this textural triangle. So you will be using that also in your practical class. So here there are 12 textural names, and based on the sand, silt and clay particles, you can find the textural name. So in the last class, I was telling about finer the soil particles, more will be the surface area. So I just want to demonstrate that today. So here you can see this is a big size particle. So 2 millimeter size. Okay. So each face is 2 into 2, 4 meters square, one face. So it has 6 faces. So the surface area of that will be 6 into 4. Okay, that is 24 millimeter square is the surface area of this big cube. So now, for example, we are dividing this into 8 cubes. So each cube will be 1 millimeter in size. So one cube has 6 into 1 millimeter, and so similar to that there are 8 cubes. So if you multiply, it will be 48 millimeter square. So now you can see this is 24 and this is 48. Okay, similarly, if you further divide, the total surface area will be increased because there will be internal surface areas. More internal surface area will be created when the bigger particles are further divided. Okay, so that you should understand, finer the particle, more will be the surface area. Okay, so that now you can understand that when the particle size reduces, the surface area will increase. So now So maybe you'll be given 70% sand, 20% silt, and 10% clay. Find the textural class name. Okay. So in that case, so here is an example. So 70% sand, then 20% clay. So both are intersecting in the sandy loam. Okay, so even you can put the clay percentage is also 10%. So all the three are intersecting into this uh, polygon, which is sandy loam. Okay, so that is how you utilize this textural triangle. And the other one is 60% sand, 10% silt, and 30% clay. So 60% sand, then 10% silt. So both are intersecting in sandy clay loam. So if you put the other one also, clay is 30%. So all are intersecting in the sandy clay loam. So similarly, if you find for your own soil, you have to calculate, first of all, you have to do the experiment and find what is the sand percentage, silt percentage, and clay percentage. Then using this textural triangle, it is very easy. You can find the textural class name of your soil. So that's so maybe I have to discuss something more about wait. Okay, so in the Stokes law, we have some assumptions and the limitations. So you should know what are the assumptions we are using in this Stokes law. And so assumptions means it is not actual. We are assuming that. Okay, so that so when we use those assumptions, that may limit the correctness of our determination. Okay. So first assumption is particles are rigid and spherical and smooth. Okay, because we are using the diameter or radius of a spherical body to calculate the time required for each particle to travel 10 centimeter using that Stokes law. Okay, so we assume that each particle is spherical in shape. Okay, but actually all the particles are not spherical. So this requirement is very difficult to fulfill because the particles are not completely smooth over the surface and the particles are not spherical. Okay, so that will limit our determination. So we assume they are spherical body, but actually they are not. So that will limit our, maybe it will cause some error. And the second assumption is particles are large in comparison with the molecule of liquid, so that in comparison with particle, the medium can be considered as homogeneous. Okay, so this one, the particles must be big enough to avoid Brownian movement. So that's why we assume that particles are large compared to the molecules of liquid. But particles less than 0.0002 millimeter can exhibit Brownian movement and that will affect the rate of falling. So maybe a very small fraction of the particles in the clay, a very small fraction may be of this size, and which can cause Brownian movement, and that also can affect the usage of this equation. Then the third assumption is the fall of particle is not hindered or affected by the proximity of the wall of the vessel or the adjacent particle. So that means the velocity of movement of the particles is not affected by the adjacent particles. So that is our assumption, and we are calculating. But many fast falling particles may drag the fine particles down along with them. For example, when sand particles are moving, due to that force, some small clay particles or silt particles also can be dragged with those sand particles. So that can also cause some error during the determination. And the other assumption is the density of particles in water and the viscosity of the medium remain constant. Okay, so that is another assumption. But maybe during determination, there can be some variation in the viscosity because of the movement of the particle. That also can be somewhat changed, so that also can be a limitation. Then the temperature is should be kept constant, but maybe during because of the variation in room temperature during your determination, we cannot control that temperature changes. So these are the limitations of determination of soil texture. Okay, so maybe the first one is the most important one. We assume the particles are spherical and smooth, but actually the particles are not spherical. So that is the main limitation of this method. And also you should have some knowledge. These are also, the other things are also the assumptions, but not always true. Okay, so that's all about soil texture. So if you have any questions, you can ask. Any doubts? Okay, so in the absence of questions, I can finish this class, and I have an announcement tomorrow. Tomorrow at what time we have the class?
8:30 to 9:30.
Yes. Yeah. So the issue is we have a field day tomorrow at the farm. So I have to attend to that function. So maybe I'll cancel the class tomorrow, and you have to give me another time during this week. Maybe not tomorrow, maybe on Friday afternoon if you have time. I can fix the class. Okay? Is it okay for you?
Okay.
Okay, so tomorrow 8:30 to 9:30, the class is cancelled. Okay, and I'll have that class in another day. Okay, huh? Okay, we can end the class. Thank you.